Hey everyone, welcome back to PythonDevOps. So here's a real scenario. You have got your app running on EC2 in one VPC and your RDS database sitting on a completely separate VPC. Maybe it's a different AWS account, maybe it's a different Teams VPC. Now the question is, how do these talk to each other without going over public internet? You could put your RDS on a public subnet, but that's a terrible idea. Never do that. You could set up VPN, but that's a complex, add latency, and is overkill for internal AWS traffic. Or you use VPC peering, a private direct connection between your two VPC using the AWS backbone itself. So no internet, no gateway, no net. That's exactly what we are covering today. By the end of this video, you will know what is VPC peering. So let's get into it. So what is VPC peering? A VPC peering is a network connection between two VPC that enable private routing using AWS backbone without internet gateway, VPN tunneling, or net devices. So what does that mean in case of practice? It means traffic between your VPC never touches the internet. It goes through Amazon own internal network, which is faster, more reliable, and more secure than routing through an internet gateway. Three things I want you to remember from this slide. First is private routing, second is low latency, third is zero cost transfer. So let's understand the private routing. Private routing means the traffic stay on the AWS network, even on the global network, never traverse the public internet. So it will be secure. Next one is low latency. If you are pairing within the same region, we are talking some millisecond latency between your EC2 instances. Third one is zero cost transfer. If both instances are in the same availability zone, you pay nothing for the data transfer. That's a big deal at scale. And VPC peering works across account and across regions, whether you are connecting your dev account to your prod account or connecting US East 1 to AP South 1. Pairing handle it. So let's go to the next topic, how VPC peering works. Now let me show you exactly how traffic flow when VPC peering is set up. On the left, we have a VPC A CIDR block 10.0.0/16. Inside it, we have got public subnet, a private subnet, and EC2 instance running in both. On the right, we have a VPC B CIDR block 172.16.0/16. Same structure, subnet, EC2 instances. In the middle, that oval, that's a peering connection, identified by a common ID that starts with PCX hyphen and with the random number. So here's what happened when EC2 in VPC A want to talk to EC2 in VPC B. EC2 in VPC A send a packet destined for 172.16 with the random IP. VPC A route table say, we have a route table in VPC A say hi to the destined IP, which is 172.16.00/16, goes through the peering connection with some random ID. The packet travel through the AWS backbone to VPC B. VPC B route table say 10.0.0/16 to the VPC A, which comes from the peering connection, and then it's accepted. Packet reaches the destination instance, which is R in VPC B. Now here's the thing I need to burn into your memory right now. AWS does not automatically add routes when you create a peering connection. This is the number one reason people set up peering and then wondering why traffic isn't flowing. You have to add the routes yourself on both sides. We will do exactly the same in the demo. Next is step by step create VPC peering. So we have a 4-step: create peering request, accept peering reconnection, update route table, update security group. I will explain in detail while we do the practical demo. Let's go to the next step. We have a real world use cases where we can use VPC peering. First, in multi-account architecture, like we have multiple AWS account for dev, stage, prod. So VPC are separate. So using VPC peering, we can connect each account with each other. Next is shared service VPC. Like you want to centralize your logging, monitoring, all the thing in one VPC, and rest of the application are deployed in the different VPC. So that's how you can use the shared service VPC. Like you have the Jenkins as well. In our company, we are using the Jenkins into a centralized VPC and rest into the application or the project in different VPC. Next is database isolation. So database isolation means keeps RDS in a dedicated VPC. So it has no public access or no public exposure, and you can peer from app VPC. Like you have deploy application into the different VPC and you can peer that. Next is microservice communication. Microservices service in separate VPC, talk privately, no API gateway needed for internal call. Means you have created the multiple API in multiple VPC. So you can create the pairing connection so they can talk to each other. Next we have a cross region. You have the multiple services or the resources are created into the different region. So you can connect via using VPC peering. Next we have EKS cluster connectivity. Like you can pair the worker node, VPC and share tooling. Like we have a ROCD, Vault, Prometheus, all the things using peering connection. So this is the real world use cases. Let's go to the next topic. limitation and common gotchas. So first one, this is the big one that confuse the most people. Let's say you have three VPC, A, B and C. You pair A with B, B with C. Naturally you think A can talk with C through B, right? Nope, that's not how pairing works. VPC pairing is strictly point to point. There is no traffic forwarding through a middle VPC. If you want A to talk to C, you create a direct VPC pairing connection between A and C. Next one is security group by ID only. Even after pairing is set up and routes are configured, if the security group on your destination EC2 or RDS doesn't allow traffic from the peer VPC, it is still getting blocked silently. Now here's the thing worth knowing. If you are pairing with the same region, you can reference the pairing security group ID directly instead of the CIDR. That's actually cleaner because if the CIDR ever changes, your rule still holds. But across regions, security group ID referencing does not work. You must use the CIDR block. So 10.0.0.16 as the source, not the security group ID. Keep that in mind if you are doing VPC pairing. Third one is pairing is not a VPN or transit gateway. People sometimes assume pairing gives them encrypting tunnel like a VPN. It doesn't. Traffic over a pairing connection is not encrypted in flight. It's a private, meaning it stay on the AWS backbone and never hit the internet, but it's not encrypted. Next one is no overlapping CIDR. If a VPC has a CIDR 10.0.0/16 and VPCB also has the same, so AWS has no idea which network to route traffic to. The pairing connection will fall immediately. Next is route table or manual, both side. You create the pairing connection, you accepted status so active, you trying to ping, nothing work. Why? Because active just mean the handshake is done. AWS does not automatically add route. You have to go into VPC A route table and add the route VPCB CIDR. Then go into VPCB route table and add the route for VPC A CIDR. So that's how you have to create the route table manually. Last one is max 125 pairing connection per VPC. Hard AWS limit can't go above it. For most setup you will never hit this. But in a enterprise environment with dozen of VPC, all pairing with the central shared VPC, you will hit it, and at that point pairing is the wrong tool. Transit gateway handle the thousands of attachment and give you transit routing on top. So up to 5 VPC pairing is fine. Beyond that, evaluate transit gateway. So that's all the limitation and common gotchas. Next is the VPC pairing versus transit gateway. I will explain in the separate video. Alright guys, that's a wrap up on the theory side of VPC pairing. We covered what VPC pairing is, how traffic actually flow between VPC, the step-by-step process, the real world use cases and the gotchas that will break your setup if you ignore them. One thing I intentionally skip, that is VPC pairing versus transit gateway, because we will cover into the dedicated video. So in the next part we are going to cover full hands-on demo, 2 VPC, an EC2 app server and a completely isolated RDS with no internet gateway, and we'll check how we can make it communicate between both of them. If you haven't subscribed yet, do it now so you don't miss part 2. And then we will cover the transit gateway as well. Drop a comment below if you have any question on the theory. I read every single one. See you in the next one. Thank you.